Welcome to qnawire.
Hi. So again, we are given a combination of three capacitors. Let me draw the capacitors first. So two capacitors. C1 and C2 are connected in parallel. To a third, and these two capacitors are connected to a third capacitor C3 in this fashion. And we have point A and point B. Let's say this is point D. So this is my C1, this is C2, and here I have C3. So I have these three capacitors. C1 and C2 are connected in parallel, and there's the C3 capacitor which is in series with C1 and C2. So this is the combination. So the value of the capacitors, let me write the values of each of them. So C1 is given to be 6 microfarad, C2 is given to be 3 microfarad, and capacitor C3 is given to be 5 microfarad. Now in the problem, it's given that some potential difference VAB is being applied between the points A and B, which is not given to us. The value of the potential difference is not given to us, and we are required to find that. So some potential difference is applied between these 2 points A and B, and it is given that after the charges on each of the capacitors have reached their final values, the charge on capacitor C2 is given to be 30 microcoulomb. So the charge on capacitor C2, let's say the charge is Q2 on the capacitor C2 is given to be 30 microcoulomb. So we are given the charge on one of the capacitors, that is C2, and in the first part of the problem we are being asked to find the charges on each of the capacitors C1 and C3. So charge on one capacitor C2 is already given, which is equal to Q2, 30 microfarad, and in the first part of the problem we need to find the charge on the first capacitor C1 and the charge on the third capacitor C3. So if you look at the problem, we see that capacitors C1 and C2 are connected in parallel, and capacitor C3 is in series with this combination of C1 and C2, which is connected in parallel. So since C1 and C2 are connected in parallel, and we know that for parallel combination of capacitors, the voltage, the potential difference across the parallel combination of capacitors is going to be equal. So if I try to redraw the part of the circuit, so I'm just drawing the part of the circuit where C1 and C2 are connected. So we have C1 like this and C2 like this. So the potential difference across this part, V2 and V1, is going to be equal because they are connected in parallel. So for these two capacitors, the potential difference across these two capacitors, C1 and C2, is going to be equal, which is equal to V1 and V2. So V1 equals V2, which is nothing but equal to, and V2 can be written as Q2 divided by C2 from the definition of capacitance. We already know the value of the charge on second capacitor, which is Q2, which is given to us to be 30 microfarad. So I write that. So your Q2 equals 30 microcoulomb and divided by C2, the value of the capacitance C2, which is given to be 3 microfarad. So this is 3 times 10 raised to negative 6 farad, and the value comes out to be 10 volts. So we found the potential across each of the capacitor V1 and V2. So having found the potential, so across V1, the potential we have found it to be 10 volt. So once we know the potential across a capacitor, we can always find the charge on that capacitor. So the charge on capacitor C1 is simply given by Q1 equals V1 times C1. So my V1 I have already found to be 10 volts. So 10 times the capacitance, the value of the capacitance C1, which is 6 microfarad. So 6 times 10 raised to negative 6 farad. And this value comes out to be, so charge on the first capacitor C1 comes out to be 60 microcoulomb. So that's the charge on the first capacitor. Q1. So we have found the charge on the first capacitor Q1. The charge on the second capacitor is already given to us. We found the charge on the first capacitor C1, which is equal to Q1, which is 60 microfarad. And now we need to find the charge on the third capacitor C3. So if you recall that the third capacitor C3, so we have our C1 and C2 like this. So this is C1, this is C2, and the third capacitor C3 is connected in series with the combination of this capacitor C1 and C2. So we already found the charges on capacitor C1 and C2 to be equal to Q1 and Q2. So if you recall that in series combination, so if I redraw this circuit in this way, so the net capacitance of the two capacitors C1 and C2 which are connected in parallel, and then I'm going to have the third capacitor which is C3. So let's call this net capacitance equals to C12. So for series combination, the total charge on each of the capacitor is indeed equal to the net charge of the circuit. So for series combination, the charge on the capacitors Q3 is indeed equal to the sum of the charge on each of the true capacitors C1 and C2. So Q3 equals Q1 plus Q2. So my Q1 and Q2, if I write the sum, so my Q1 was 60 microfarad. Sorry, the Q1 was 30 microfarad, and we found that Q2, so Q1 is 60 microfarad and Q2 is 30 microfarad. And if I take the sum, it's going to be 90 microfarad. So this is the charge on the third capacitor Q3. So with this, we have successfully completed the first part of the problem. We have found the charge on capacitor Q3, Q1, and charge on the second capacitor is already given to us. So the second part of the problem is we need to find the equivalent voltage, the potential difference across the points A and B. So for finding the potential between the points A and B, so the potential between the points A and B is simply given by the ratio of the net or the equivalent charge of the circuit and the net or the equivalent capacitance of the combination of three capacitors. So as you can see from the first page that these three capacitors, two of them C1 and C2 are connected in parallel to a third capacitor which is connected in series with the combination of C1 and C2. So in order to find the net capacitance, we first need to find the equivalent capacitance of C1 and C2 which are connected in parallel. So for that, I'm just going to write it simply like this. So let's say C12 is the equivalent capacitance of the parallel combination C1 and C2. And here we have C3. And these are my points A and B. So since C1 and C2 are connected in parallel, so the net capacitance C12 is simply the sum of the capacitance. So C1 plus C2, which is going to be 6 microfarad plus 3 microfarad, so which is going to be equal to 9 microfarad. And if I want to find the equivalent capacitance of this combination, so it's going to be C equivalent. So since the capacitors C12 and C3 are connected in series, so the net capacitance of the circuit is going to be 1 over C equivalent equals 1 over C12 plus 1 over C3. And if we calculate this, it's going to be 1 over 9 microfarad plus 1 over 5 microfarad, the value of which comes out to be around 3.21 microfarad. So this is the equivalent capacitance of the circuit of the combination of three capacitors C1, C2 and C3. So this is the equivalent capacitance. Good. So our job is to find the potential difference between the points A and B, which is given by the total charge, the equivalent charge divided by C equivalent. And if you guys are wondering if we know the value of Q equivalent, we have already found that, because as you can see in this part of the circuit, the Q equivalent or the total charge between the points A and B is going to be equal to the charge across the capacitor C3, which we already found. The charge across capacitor C3, which is equal to Q3, is 90 microfarad. So we have the total equivalent charge 90 microcoulomb divided by the equivalent capacitance, which is 3.21 microfarad. And if you take this, if you calculate this value, it comes out to be 28.04 volt. So this is what the value of VAB is. So finally, my VAB equals 28.04 volts. This is the potential difference or the potential applied across the points A and B.